Hello students, we have been dealing with the unit light and this is the last portion of unit light and it is spectrum. So in the unit light, we are dealing with refraction this year. So last year maybe you studied about reflection, this year you are studying about refraction, and the coming years maybe in plus 1 and plus 2 you will be learning about diffraction. So here in the case of refraction, our chapter began with refraction through different mediums. Then we used prisms for refraction. Then we studied about lenses, and now we are studying about spectrum, which is also formed due to the property of refraction. We will just do a small recap of what we already learned. So you remember a glass slab, and you learned that when a light ray is incident obliquely on a glass slab, it undergoes refraction at its both surface. Okay, if the glass slab is rectangular in shape, the incident light ray will be laterally displaced. There will be a lateral displacement. The path of the incident light ray will be parallel to the path of the emergent ray. And there is no deviation, only lateral displacement is there. There is no deviation if you are using a rectangular glass block, there is only lateral displacement. But it's different for the case of a prism, which we have learned. So in the case of a prism, when a light ray falls on one surface of the prism, it gets refracted in that surface. It reaches the next surface by passing through the prism. Then again it undergoes refraction and goes out. Here when you trace the path of the incident ray and the direction of the emergent ray, we can see that there is deflection or deviation. So this is the path of the incident ray, and when the emergent ray is produced backwards, here you get an angle, and this angle is represented by the symbol delta, and that is called angle of deviation. So prism produces deviation, a rectangular glass block does not produce deviation. So I am going to name this prism as A, B, C, and the light ray as P, Q, R, S, and here we have a normal which I'll draw in the dotted line here. Here also we have a normal to the surface of the prism, and here we have angle of emergence, angle E. Here we have angle of incidence, angle I, and here we have first deviation which is represented as delta 1, here first deviation delta 1, and here we have second deviation which is represented as delta 2. When you add both deviations, you will get the total deviation. Here is the angle. So a prism deviates the light ray, and this angle of deviation depends mainly on 4 factors. The first factor is angle of incidence. Angle of incidence. When we increase the angle of incidence or decrease the angle of incidence, the angle of deviation at first decreases, reaches a minimum, and then increases. So when you are increasing the angle of incidence from 0 towards 90 degree, what you see is that the angle of deviation at first decreases, reaches angle of minimum deviation, then again it keeps on increasing. So this position of the light ray, as we are seeing on the board right now, is the position for angle of minimum deviation. In the case of minimum deviation, the light ray inside the prism will be parallel to the base. In a figure, if the light ray is passing parallel to the base inside the prism, then this is the position of angle of minimum deviation. We can draw figures which are not in a straight line like this. This is not parallel, they are not parallel to each other. And if you draw like this, it can also go like this. This is also not parallel to the base. If you draw the light ray inside the prism to be parallel to the base, then we are drawing actually the picture of angle of minimum deviation. Okay, so angle of deviation depends on the angle of incidence. That's number one. Angle of deviation depends on angle of incidence. Second one is the angle of deviation depends on the angle of the prism. When the angle of the prism increases, angle of deviation also increases. The second case, the angle of deviation depends on. So, deviation depends on 1. Angle of incidence, 2. Angle of the prism, and 3. The refractive index of the material of the prism. There can be glass prisms, glass can be of different types, there can be water prisms, there can be rock salt prism, quartz prism, different types of prisms are there, diamond prisms. If you are using prisms of different material, its refractive index can change. So, when refractive index changes, angle of deviation also changes. Higher the refractive index, more will be the angle of deviation. So, it depends on refractive index of the prism. And number 4, it depends on wavelength of the light. It depends on the wavelength lambda of the light. Higher the wavelength, lower will be the angle of deviation. Lower the wavelength or smaller value for wavelength, more will be the deviation. So, remember this one, angle of the prism is directly proportional, and material of a refractive index of the material is also directly proportional, but this one is inversely proportional. Inversely proportional, wavelength increases, angle of deviation decreases, wavelength decreases, angle of deviation can increase. So, when it comes to wavelength, we can look into detail what is regarded to wavelength. So, this is the factors on which angle of deviation depends. Okay. Then, when it comes to wavelength of light, we represent wavelength by the symbol lambda. Then light has one more main feature, that is, it has a light wave has frequency. Light wave has wavelength and light wave has frequency. When you multiply them both, you get the velocity of light. The velocity of light is a universal constant, and you know its value by heart. It is 3 into 10 to the power 8 meter per second. 3 into 10 to the power 8 meter per second is the value of velocity of light. It is a universal constant. Okay, and this velocity is exhibited by light when it is traveling through vacuum. When it is traveling through vacuum, and when it is traveling through different mediums of different optical densities, then their wavelength will adjust. Wavelength will adjust so that this value can be decreased. So, we when it is traveling through a medium, we represent it, instead of C, we represent it with V. Velocity is represented by V, which is wavelength into frequency. Okay. So, if velocity remains constant, then if frequency increase, wavelength should decrease. If wavelength should increase, then frequency should decrease. If they are traveling in vacuum, this wavelength light ray, for example, red light has higher wavelength. Red light has higher wavelength. Wavelength of red is higher than lambda wavelength of violet light. So, violet light has smaller wavelength, that means waves are smaller, and red light, the waves are longer. Wavelength of red light is large and the wavelength of violet light is small. Smaller the wavelength, more will be the deviation. More will be the deviation. Remember, here we have drawn this picture here, and we can see that the light, we said that PQ is a light ray. We said that PQ is a light ray, but we see that PQ is actually passing straight inside the prism and there is no problem, because we are using a light ray of single wavelength. We are using a light ray of single wavelength or single color, and that color is usually yellow. We use yellow color light, which is produced by sodium vapor lamp for doing prism experiments. Like calculating the angle of the prism or some other details, we use yellow light. But what happens if we use white light? What happens if we use white light? So I am going to rub this figure. Okay, white light. In earlier days, physicists thought that white light is a homogeneous matter. They considered light to be matter at time. Then they considered that it is homogeneous, that it is uniform. We cannot split light into any components. But later Sir Isaac Newton discovered that white light is actually a combination of 7 different colors. So he found that by using a prism. It was around the 1800s, he found it, 1801. So he used a prism. At first he allowed white light to enter into his room through a small slit into a dark room, and that white light was allowed to fall on a prism. But to his surprise, what happened was that white light was split into different components. And again it was bending at different angles. Different parts of the white light were bending at different angles. So I am drawing 7 lines here to represent the 7 colors he saw there. So the white light was splitting into 7 components. Why this splitting happened? This splitting happened because white light is a combination of rays with the different wavelengths. We already said that the wavelength of red is more than the wavelength of violet light. And while studying the factors affecting deviation, we discussed that higher the wavelength, less will be deviation. So what happens is, when white light with all the 7 colors reached this side of the prism, the red light, which has a higher wavelength, did not deviate much. It did not deviate much. Light ray should have actually gone in this direction. Only a small deviation happened to which color? Red color light ray. But violet light, which has a lower value for wavelength, deviated more. Low wavelength, small wave, violet light deviated more, and it reached towards the bottom of the prism, or reach towards the base of the prism. Lower wavelength, higher deviation, more deviation. It should actually go in this direction, but actually it went in the highly deviated direction. So other colors in the 7 colors were distributed evenly, like violet, indigo, blue, green, yellow, orange and red. And together we call them with the acronym VIBGYOR. So VIBGYOR: violet, indigo, blue, green, yellow, orange, red. So sometimes in small class when we draw VIBGYOR or rainbow colors like this, we tend to draw from violet here and red here, but actually this is what happens when it comes to a prism. Violet is deviated the most and it comes to the bottom, and red is deviated the least. And you know the reason why this is happening. What is the reason? Because of difference in their wavelength. To make it more technical, we use the term refrangibility. Okay, refrangibility is the angle through which a light ray of particular wavelength can deviate while passing through a prism. What is refrangibility? It is the angle through which the light ray of a particular wavelength can deviate while passing through a prism. So, refrangibility, due to difference in refrangibility, the light rays will split into its component colors, especially white light will split into its component 7 colors, and this splitting of the white light into its component colors by a prism is known as dispersion. So, what is dispersion? The splitting of white light into its component colors while passing through a glass prism is known as dispersion. And what is the cause of dispersion? It is refrangibility or difference in refrangibility. Different light rays or light rays of different wavelengths have different refrangibility, and refrangibility means the angle through which a light ray of a particular wavelength can deviate while passing through a prism. And you know that refrangibility is related to wavelength. When wavelength increase, less refrangibility. When wavelength decrease, more refrangibility. Okay. And difference in refrangibility of component colors or component wavelengths in the white light causes it to disperse, or we call it as dispersion. And if we keep a screen over here, we will get different colors here. Red color merging into orange color, yellow color, green merging into blue, indigo and violet. And this band of colors or the band of wavelengths obtained on a screen is called spectrum. What is it called? Spectrum. The band of colors which is obtained on a screen after dispersion through a glass prism is called spectrum. Okay, this spectrum can be a pure spectrum or an impure spectrum. Usually if we take a prism from our school and we pass light ray and we get a band of 7 colors, and it will be one color will be merging into another color, red merging into orange, red merging into yellow, merging into blue, green, like that. If it is merging like that, then it is called impure spectrum. To obtain a pure spectrum, we need a device called spectrometer. Okay, spectrometer is a device with which we can obtain a pure spectrum. So, we need to know what is a pure spectrum. Okay, spectrometer is an arrangement of many lenses in a tubular structure, and it allows the light ray to enter in a parallel beam, and the emerging light rays will be collected and individual colors will be separated from each other. So, when you are using a spectrometer, the spectrum will be a band of different colors. All the colors will be separated by bands. So, violet color band, indigo color band, blue color band, green band, yellow, orange and red. If all the colors are separated in different lines, then we call it a pure spectrum. Okay. To obtain a pure spectrum, we need a device called spectrometer. And spectrum is the band of colors obtained on a screen after dispersion through a prism. Okay, I hope this much is clear for you. Now we will move on to the next part. Okay, spectral light. For obtaining a pure or impure spectrum, we need a source of light. Usually sunlight is a very good source for obtaining all colors of the light. For doing experiments, we don't want all colors. Sometimes we need a single line of ray to study about the angle of deviation or something like that related to a prism. If you are studying such property, we need a wavelength. We need a light ray of a particular wavelength. So in that case, we use lamp, different types of lamps. Sodium vapor lamp produces yellow colored light of 589 nanometer wavelength. Then we have mercury vapor lamp, which produces light ray in the range of silvery white color or white light. Fluorescent light produces white light. Sunlight gives us a mixture of all 7 colors, that is again white light. Then we have Bunsen flame, which actually contains blue color and yellow color. Sometimes it can even be colorless flame. Then we have carbon arc lamp. These are the sources of spectral colors. And the spectral colors can be arranged in the order of violet, indigo, blue, green, yellow, orange, red. So we will just plainly look at the approximate values of their wavelengths. Violet. Violet, we can say it has a wavelength in the range of 4000 Armstrong unit. When it comes to red, its wavelength is near to 8000 or 7600 Armstrong unit. So up to 7600 Armstrong unit. Sometimes it is represented as 8000 Armstrong unit. It ranges from 6300 Armstrong unit to 7600 Armstrong unit. And violet light is usually from 4000 to 4460 Armstrong unit. And other colors fall in between. Just remember this value. 4000 is the range of wavelength range of violet, and 6000 to 7000 or 8000 is the wavelength. 7000 to 8000 is the wavelength range of red. So who has higher wavelength? Red. Who has lower wavelength? Violet. Who is refracted or deviated more? Violet. Lower wavelength, more deviation. Higher wavelength, less deviation. Remember that. Who has higher frequency? They are all traveling at the same speed. Red, higher wavelength, less frequency. Violet, less wavelength, higher frequency. Then only when you multiply frequency and wavelength, we will get same velocity for both of them when they are traveling together in a medium. Okay. Now I mentioned earlier about, when I mentioned about light, I said about certain properties of light: reflection, refraction, and we have one more, which is diffraction. So reflection, you know what is reflection, you know what is refraction, and now we have diffraction, which we are not going to study this year. But when scientists studied about diffraction, they came to the conclusion that light is not particle matter, but light is actually wave matter. Light is made up of wave. Light is actually transverse wave which have crests and troughs. And crests and troughs are arranged in such a way that two types of waves are there. Electrical and magnetical disturbances are there in a wave of light. Electrical and magnetic disturbances are there in the transverse wave of light. And we call such waves as electromagnetic waves. Light ray actually falls into the category of electromagnetic waves. They are composed of electrical and magnetical disturbances like transverse waves. Actually, light forms a very small part in the vast electromagnetic spectrum. So electromagnetic spectrum contains various waves such as gamma rays, X-rays, ultraviolet rays, visible light rays, infrared rays, microwaves and radio waves. I will write them all in the increasing order of their wavelength. First one is gamma rays, second one is X-rays, third one is ultraviolet rays, fourth one visible light rays, fifth one infrared rays, microwaves, and seventh one is okay. So in this list, gamma rays have the smallest wavelength, so they are the smallest waves, and radio waves are the longest waves, or they have the largest wavelength. Their waves are very large. It can be even as large as 10 or 100 kilometers. So radio waves have the largest wavelength and gamma rays have the smallest wavelength. The wavelength is distance between two consecutive crusts or two consecutive crusts. Then X-rays and all other rays fall in between this range. And visible light ray forms a very small region in the whole electromagnetic spectrum. So the value for gamma ray is in the range of 10 raised to minus 14 meters. And when it comes to radio waves, it is 10 raised to 4 meters. Look at the difference in their values. One is nearly 10,000 meters, that is 10 kilometers in size. The other one is in the range of minus 14, power of minus 14 meters. So they have a vast difference. And in between falls the light ray, which forms or which falls between 4 into 10 raised to minus 7 meters to 8 into 10 raised to minus 7 meters, that is visible. Okay, this is the list of electromagnetic rays in their increasing order of wavelength. Least is gamma ray, X-rays, then bigger one is ultra. Visible light ray has larger wavelength, infrared has larger wavelength than visible, microwaves are bigger than infrared, and radio waves have the longest wavelengths we know. And these are the 7 rays which constitute the electromagnetic spectrum. And they have some characteristics. We already know some characteristics related to light. So characteristics of light are applicable to these electromagnetic waves also. We know that light travels at a constant speed known as c, and what is its value? It is 3 into 10 to the power 8 meter per second. Similarly, all the electromagnetic waves travel at that speed when it is passing through vacuum. First point. Second point, all the electromagnetic waves can travel through vacuum. They don't want any material medium for its propagation. Electromagnetic waves can pass through vacuum. They don't want a material medium for its propagation. Okay, number 3 is that electromagnetic waves, the properties like reflection, refraction, diffraction. So all the 3 properties which we earlier discussed about visible light ray is applicable to all the electromagnetic waves. And next, they are generated by electrical and magnetic disturbances. And finally, they are all transverse waves. Remember, all the waves are transverse waves. So what are the characteristics of electromagnetic waves? They don't want a material medium for its propagation. They all travel at the velocity of light in vacuum, which is 3 into 10 to the power 8 meter per second. Then they all express the phenomena like reflection, refraction and diffraction, and they are produced due to electrical disturbances, and finally they are all transverse wave. Now we are going to discuss in detail about the properties, how source and its use about ultraviolet and infrared. Infrared and ultraviolet. Infrared has longer wavelength than visible, ultraviolet has lower wavelength than visible light ray. And we know that visible light ray is from violet region to red region. Here comes the violet, which is shorter wavelength, and here comes R. So what is after R here? That is infrared, and below this violet or above this violet we have ultraviolet. First we will discuss about how infrared rays were discovered and what are its characteristics and uses. While using a prism to refract light, William Herschel in 1800 found that above the red region, when he was studying about the nature of these rays, he was studying how much temperature each part has, what color, what depth, and while he was using a thermometer to study, he placed a thermometer here, and when he placed a thermometer here, a sudden rise in temperature was shown when the thermometer was moved to this region, which is just above the red region. So he said there is an invisible ray in that region, and he called it infrared radiation. And the characteristic of infrared radiation, one, they travel at the speed of light, which is 3 into 10 to the power 8 meter per second. They can travel through vacuum. They don't want material medium for propagation. They show properties of reflection and refraction, and they are scattered less than visible light. These light will be scattered. Scattering is not included in syllabus this time. Scattering is actually the spreading of the light ray due to particles in the atmosphere. So you know fog, mist and all. If fog and mist is in the atmosphere, the light will not pass through it. Light will be reflected back or dispersed in different direction. And here, if we are using a red light or light in the range above this R, red, we have the infrared radiations there. Infrared radiations are less scattered than visible light. So we can use infrared radiation for purposes like taking photographs at night, or taking photographs where visibility is reduced due to mist or fog, or taking photographs which are far away from the subject. Okay, such applications are there for infrared radiation. Then infrared radiations have the property of heating effect. So they can be easily detected by their heating effect. So sun is a good source of infrared radiation. That's why when you stand outside in the sun, we feel the heat. Infrared radiations are blocked by glass. So if you are using a glass prism, most of the infrared radiations will be absorbed by this glass prism. So we will not get enough infrared radiation for studying. So what we do is we use a rock salt prism, because rock salt or salt do not absorb infrared radiations and they will allow infrared radiations to pass through it. So we use rock salt prism to study about infrared radiations, and they do not affect ordinary photographic films. We have to use treated films for that. Nowadays we are in the digital platform and there things work differently. Then infrared radiations can cause heat. Therefore, they can be detected by using devices like thermometer or thermopile. And where do we find use of this? Infrared radiations are used in photography. Infrared radiations are used in the searchlights for making the light travel a long distance without any scattering. And infrared radiations are actually used for communication. In television and remote control device, we have a small light at the tip of the remote, which is actually an infrared transmitter. When you press the button, these infrared transmitters will light up and they will send signals to your television to change channels or tune it. Then these infrared radiations are used for heating substances, like in the case of devices like solar heaters and all, we make use of infrared radiations. The heat from the sun is collected in the infrared form and they will be used for heating water. Then infrared radiations are also used in warfare. When a plane travels through the sky, the engine produces a lot of heat, and these heat targets can be locked using infrared locks, and missiles can be targeted towards these locks. So we can destroy an enemy plane or an attacking plane by using the technology developed with the help of infrared radiations. Okay, these are the main uses and sources and characteristics of infrared radiations. When we are going to ultraviolet rays have smaller wavelength than that of visible violet light. So ultraviolet rays actually fall on this area, and it was actually detected by Professor J. Ritter while he was placing a photographic film over there. The film was darkened by this region here after the violet or below the violet. This region actually darkened the photographic plate. So he discovered a ray which is over there, and he named it ultraviolet, which has a lower wavelength and higher frequency than that of violet light ray. And this violet light ray could be captured with the help of special photographic films which have silver chloride in it. Normal light rays from red to violet region does not affect a silver chloride plated photographic film, but a photographic film coated with silver chloride can detect ultraviolet rays. And ultraviolet radiations are produced by very hot objects. Like sun is one of the best source of ultraviolet radiations. These ultraviolet radiations does not reach us in full effect due to the presence of atmosphere, and especially that layer on the atmosphere called the ozone layer. They absorb most of the ultraviolet radiations. Okay, now regarding the characteristics of ultraviolet radiations. Ultraviolet radiations travel in vacuum with a velocity of 3 into 10 to the power 8 meter per second. They do not require any material medium for its propagation. Number 3, they shows the property of reflection and refraction like other electromagnetic waves. Number 4, they are absorbed by glass. So if we are using a glass prism, most of the ultraviolet radiations will be absorbed by it. So we have to use a different prism. It is quartz prism, Q-U-A-R-T-Z, quartz prism. For detecting infrared radiations, we use rock salt prism. For ultraviolet radiations, we have to use quartz prism, because quartz will not absorb ultraviolet radiations. Quartz will allow ultraviolet radiations to freely pass through it. And these ultraviolet radiations are capable of causing fluorescence in substance like barium sulfide and zinc sulfide. And owing to its shorter wavelength, ultraviolet radiations are scattered the most. Comparing infrared rays, visible light rays and ultraviolet radiations, ultraviolet is scattered the most and infrared is scattered the least. Uses of ultraviolet radiations. Ultraviolet radiations have the capacity to destroy bacteria. So ultraviolet radiations are used in medical field for disinfection. Ultraviolet radiations has the property of causing fluorescence, which helps us to create authentic documents. Ultraviolet radiations help us to detect fake documents or fake signatures or forged signature. If you rub something on a document and rewrite it, if you keep it under ultraviolet radiations, then you can detect the changes which have been made in the document. Ultraviolet radiations are used for detecting purity of gems and purity of diamonds, etc. Ultraviolet radiations are used for checking the purity of mineral samples. And finally, these ultraviolet radiations can be used in the field of surgery. They have very short wavelength and therefore they can be directed precisely into certain regions, like operating eye, like LASIK surgery. For LASIK surgery, they use ultraviolet radiations to precisely remove certain unwanted part or shape up our lens, and that is done using ultraviolet technology. Remember, ultraviolet rays are also harmful if we get its whole impact on our skin directly from the sun. If you stand outside in the sun for a long time, these ultraviolet radiations cause increase in production of melanin, which turns our skin to a darker tone. And long exposure to ultraviolet radiations can cause an ionizing effect, and our skin starts producing tumors if you are exposed to ultraviolet radiations in a high amount. That can even lead to cancers. Then finally, ultraviolet radiations are produced by very hot objects, like in the case of welding. That is why people use shields to cover their eyes while doing the process of welding, and looking directly into sun is not recommended due to the ultraviolet radiations coming from the sun, which can destroy our retina. So these are the main points with regard to spectrum. So remember what is spectrum and how is a spectrum obtained, what is dispersion, how is dispersion caused, refrangibility is the reason for that, then electromagnetic waves, and electromagnetic waves are arranged in increasing order of their wavelength, and the properties of ultraviolet and infrared and their uses, and some values related to visible light ray, that is wavelength of violet and red. Please use your textbook to refer to other points, and these are the main important points with regard to the ICSE syllabus given this year. Okay, now you can try to solve the question answers in the ICSE question given in your book. If you have any doubts, you can contact me. We will meet again in the next class with another topic. Thank you all.